A very good day to respected lecturers and everyone present. Today, I would like to share my final year research project entitled Design of a Solar-Powered Hydroponic Irrigation System. Hydroponics has been experimented with since the 17th century and has many benefits such as controlled irrigation, reduce of chemical usage, and saving space. It was found that controlled irrigation was 30% more efficient compared to manual irrigation. A solar-powered hydroponic system also provided a stable source of power which was essential in Malaysia due to common power disruptions which would cause the plants to have stress. The objective of this project was to design a cheaper and efficient drip irrigation system based on the transpiration rate of the plant, which would be determined using weight irrigation. Another factor would be adopting an existing photovoltaic panel designed to power the irrigation system and to study the effects of the irrigation system on the growth of the plant. The drip irrigation system was found to have better efficiency and uniformity compared to other irrigation systems. This was because the drip nozzle was placed directly at the root, which would reduce the wastage of the solution and decrease root growth. To determine the period where the drip irrigation should be initiated, the transpiration rate of the plant should be determined to ensure the solution would be absorbed by the plant would be maximized. Soil moisture sensors, which could be used to determine the transpiration rate, were dependent on the depth, thus having lower sensitivity and accuracy. Weak sub irrigation was a better alternative to determine the transpiration rate of the plant. Solution would flow from the container to the medium using cohesion and addition force until an equilibrium was reached. As the plant root takes up more liquids, the medium would have less liquids, causing the capillary rise to increase until equilibrium was reached again. Stability in the liquids obtained by the plant was important. However, instability in power in rural areas could affect the liquid stability. Thus, alternative source to power irrigation systems was required. As sunlight in Malaysia was available 4 to 8 hours a day, photovoltaic panels could be used to power the irrigation system. To obtain maximum efficiency from the solar panels, the angle of the panel should be 0 degrees as Sarawak was at the equator. Based on the research done, the methodology was developed. A thorough review on the drip irrigation system, error transpiration using weight irrigation system, and capabilities of the photovoltaic panels in Malaysia should be done. The equipment required for this project was purchased and the effectiveness of different types of and quantity of wicks should be determined. The soil density and the height difference between the solution and the medium should also be investigated. The solution would be controlled using pH, EC, and temperature sensors to ensure external factors would not affect the plant growth. The optimal angle of the solar panel should also be determined. Following these factors, the solar power hydroponic irrigation system would be built. The rate of solution taken up by the plants would be determined and the growth of the plant would be evaluated. This is a model of the solar power irrigation system. A reservoir container was used to hold the solution, holding the water and nutrients. From the tank, a pipe holding wick was used to allow the solution to flow from the reservoir container to the pot where the plants were located. A water level sensor was used to determine the volume of solution within the tank as the maximized transpiration rate was reached. The pump will be initiated if the temperature was below 30 degrees Celsius, and it will be initiated until 0.5 liters of liquids was provided to the plants, as this was the tomato plant's daily requirements. Excess solution would flow out from the outflow and recycle. As a vacuum valve would be used to control the flow of solution and prevent debris from being sucked into the tubing. The solar panel was used to power the system. Following this is the preliminary result of what has been done so far. This liquid sensor was connected using Arduino, and at different points, the liquid was measured against time and plotted using MATLAB. Based on the transpiration rate of the plant, The water level detected by the water level sensor within the reservoir tank will decrease until the transpiration rate was maximized. When the transpiration rate was maximized, the pump would be initiated to provide water for the plants using drip irrigation to provide the 0.5 liter of solution for the plants. The pump would not be initiated if the temperature detected by the temperature sensor was above 30 degrees Celsius. This is because when the temperature was above 30 degrees Celsius, the medium would dry out and the water received by the plants would not be sufficient. That is all for my presentation today, and I would like to express my gratitude to everyone that has helped me with this project. Thank you for your attention.